So in this video, we're going to integrate a rational where the numerator degree is bigger than the denominator degree. Anytime I see this, I should automatically be thinking long division here to simplify before I start trying to integrate this. The reason I want to do that is because whenever I'm using U-substitution, really the only time that my U-substitution is going to work is when that degree in the denominator is larger than the degree in the numerator, right? So if I had something like integral of x plus 1 over, x squared plus 2x, then that's something that I could use a U-substitution for. X squared plus 2x and du would equal 2x plus 2 dx, right? And I could factor a 2 out and I have x plus 1 dx going on in here. And that would cancel with this here. And then I would have my x squared plus 2x canceling out through there. Okay, I just have to deal with that coefficient, which is no big deal. Now, with this situation that we have here, with the numerator degree is larger than the denominator degree, so that falls apart for our U-substitution. So what we need to do is some long division and see if this simplifies. So if I have like 5 divided by 3 here, the numerator, okay, is what goes inside the house, and the denominator is what goes outside the house. So I'm going to put the denominator outside, the numerator inside. I'm going to start working through, see if I can simplify this. So what can I multiply by x squared to get x cubed? Well, I can multiply that by x. And if I distribute through, I get x times x squared is x cubed. X times 2x is 2x squared, and x times 1 is x. Okay, so I'm going to put an x up top here to represent that x that I multiplied by. I'm lining up the constants and the linear terms together. I don't have any squares or x cubes. So I'm going to write this out underneath. I'm going to draw the line, and I'm going to change the sign. So this becomes negative, so that's going to cancel. This becomes negative 2, and positive 4 makes a positive 2. Negative x and a positive 8 make a positive 7. I'm going to bring the 5 down, and so I have plus 5. So now the question becomes, what do I multiply x squared by to get 2x squared? Well, I'm going to multiply it by 2. So I get 2x squared, and then I get 2 times 2x is 4x, and then I get 2. So what do? I'm going to put a plus 2 up here for that plus 2 I multiplied there, just like I put an x here for that x that I multiplied there. So I'm going to draw the line, change the sign. So these are going to cancel. Look, if those first terms don't cancel, then you done messed up. Okay, so that's how you know that you picked the wrong thing to multiply by. That's the whole purpose of this long division. You're trying to knock those terms out, right? So if I add those together, 7 minus 4 gets me 3. And then 5 minus 2 gets me 3 again. So this is going to be 3x plus 3 here. And then I divide. Well, what do I divide by? I'm dividing by this x squared plus 2x plus 1. So this big nasty thing simplifies to x plus 2 plus this thing right here. Now, why is that helpful to us? Well, I know how to integrate x and I know how to integrate 2. It's this last bad boy right here that I might have a little bit of trouble with, but let's just take it one piece at a time. X squared divided by 2, and then integral of 2 is 2x. And now I need to integrate this last piece, so I'm just going to rewrite it. I'm going to factor the numerator. I'm going to pull a 3 out of each of those terms, so that leaves me with an x plus 1. Okay, so now I've got the answer here. That was the integral of x. I've got the answer here. This is the integral of 2. And so I just need to integrate this thing right here. To do that, I'm going to do a U-substitution. And so I'm going to make U equal to the denominator because I see that the denominator degree is 2 and the numerator degree is 1. So I might see some natural log business going on here. So what am I going to do? Well, I'm going to pull this 3 out front, okay? So I'm going to make U the denominator. And so that means this becomes U, okay? And now I need to find du. Du, the derivative of u, is 2x plus 2, okay? And then times my differential dx. Now, this doesn't look exactly like this, does it? Okay? So what I've done so far is I pulled the 3 out front. So how do I make a 2x plus 2 look like an x plus 1? Well, I can factor out a 2 here. And if I divide everything by 2, okay, if I divide everything by 2, I get 1/2 du equals, well, the 2's cancel to get this right here. Okay? So that's exactly what we want. I want to replace this piece right here with that piece there. So I have 1/2 du plugged into there. So I get the 2 on the outside and the du on the inside. That's understood to be 1/2. Okay? Dividing by 2 is the same as multiplying by a half. So now I need to integrate. So I have 3 halves. Pulled out front, the constant integral of 1 over u is absolute ln absolute value u plus c. But what is u equal? U is equal to x squared plus 2x plus 1. So my final answer here, this first part stays the same. Okay. And now I have the integral here, which gives me 3 halves. Ln absolute value, what is u equal? U is equal to x squared plus 2x plus 1 plus c right here. So this complicated thing right here broke down into 3 separate integrals. The first 2 integrals were pretty simple to do. This last one here required a U-substitution. Anytime I see a u and then its derivative up top right there, I should automatically be thinking my answer is going to be in the form of ln u absolute value u. Okay, that's just how that goes. Next up here, I see that I have a problem where I take a rational again. Now this one here is a little bit more complicated because I've got square roots going on in here, but I can algebraically simplify this before I do anything. So I'm going to divide and conquer. I'm going to divide this through here. I'm going to divide that through there. And I'm going to divide this through here. So x cubed divided by x simplifies to x squared. And then this right here becomes negative square root x over x, and then the last one here becomes 3 over x. So if I simplify here, once again, this becomes x squared, and then this next one here, I have a square root x over x. Well, x is equal to the square root of x times the square root of x. So I can see that one of those square roots cancel, so I have 1 over the square root x whenever that simplifies. For my integrand there. And the last one is just, I'm going to pull the 3 out front and have it 1 over x. Now, whenever I integrate this here, all I need to do is use the power rule here. If I use the power rule, add 1 to 2, I get x to the 3 divided by 3. And then I have my minus. Okay, this right here will simplify. I can write this as a rational exponent, x to the negative 1/2. Okay, remember, if this is 1 over x to the 1/2, when I flip it, it becomes x to the negative 1/2. So if I add 1 to the exponent here, that becomes x to the 1/2, and then I divide by 1/2. Dividing is the same as multiplying by the reciprocal, so that becomes 2x to the 1/2, which is equal to 2 square root x there. Okay. And then whenever I integrate here, the 3 stays, but the integral at 1 over x is ln absolute value of x. And then my plus c. Simplified here. All this is staying the same. All I need to do is flip this around, so negative 2x, or negative 2 square root x, rather. All right, so that covers 2 little tricks, algebra tricks that you can use before you start trying to do U-substitutions or applying your